Hello students. The topic magnetic effects of electric current. There's an interesting anecdote behind it. A scientist named Hans Christian Ørsted accidentally discovered this the relationship between electricity and magnetism when he noticed that accidentally that whenever he was working on circuits, and whenever the circuit would be turned on, magnetic compass lying nearby would show the deflection, and he did it over and over again, and then it came into light that there was a definite connection between the electric current and magnetism, and thus this helped us in understanding the magnetic effect of current. In this circuit also you see this wire XY. When the current is, whenever the circuit is turned on, the needle of the compass will deflect, and this is as per what Ørsted had observed, and the unit of magnetic field strength is Ørsted to honor the contributions of this scientist. Today I am going to talk about the differences between the permanent magnet and electromagnet. So permanent magnet is the one which will remain a magnet forever, like it is not going to lose its magnetism, whereas electromagnet, as the name indicates, will behave like a magnet as long as there is flow of current through it. Moment the current stops flowing, then the magnet loses its properties. तो जो इलेक्ट्रोमैग्नेट है ये रहेगा मैग्नेट जब तक इलेक्ट्रिसिटी का फ्लो उसके थ्रू हो रहा है, और जो परमानेंट मैग्नेट है वो हमेशा के लिए मैग्नेट ही रहता है. So this is one thing that we need to know when we are comparing the permanent magnets with electromagnets. So you can also say that electromagnet is temporary one, right? And since it is a temporary one, so there is a lot which depends on the amount of current flowing through the magnet. If we are passing more current through the magnet, electromagnet will be stronger. If the flow of current is less, then it will be weaker. Then of course, if we are changing the direction of current, for example, I am trying to convert this wire into an electromagnet, and I reverse the terminals. So what will happen? The flow of current will now change, and whatever polarity this magnet acquires in the first instance will get reversed in the second. As soon as you reverse, जैसे करंट का डायरेक्शन आप उल्टा करेंगे तो पोल्स जो हैं वो बदल जाएंगे. जो पहले नॉर्थ पोल था वो साउथ पोल हो जाएगा, और जो साउथ पोल है वो नॉर्थ पोल बन जाएगा. तो पोलैरिटी एंड द स्ट्रेंथ ऑफ इलेक्ट्रोमैग्नेट कैन बी चेंज्ड, whereas in a permanent magnet the polarity and the strength remains the same. So this is very, very important when we understand the difference between the permanent magnet and electromagnet. Now you can just see, if we want to write the differences, you can say that permanent magnet retains magnetic properties and electromagnet loses magnetic properties when current stops flowing. The second difference you can mention is magnetic strength does not vary. So जो भी उसकी strength होती है वो constant रहती है, बदलती नहीं है. And in case of electromagnet, the magnetic strength it varies according to the amount of current flowing through the magnets. Then third point of difference, they have fixed poles. जो परमानेंट मैग्नेट का नॉर्थ पोल है वो हमेशा नॉर्थ रहेगा, जो साउथ है वो हमेशा साउथ रहेगा. बट इन केस ऑफ इलेक्ट्रोमैग्नेट्स द पोल्स चेंज इफ फ्लो ऑफ करंट इज रिवर्स्ड. जैसे ही हम करंट का फ्लो उल्टा करेंगे, नॉर्थ साउथ बन जाएगा, साउथ नॉर्थ बन जाएगा. एंड आई होप दिस टॉपिक इज क्लियर. लेट अस नाउ अंडरस्टैंड द types of electromagnet and the fields that are created around them according to their shapes. The first electromagnet that we study is a straight conductor. And before I take that, please try and see the difference between these two circuits. If you look at these circuits, they appear seemingly identical, but if you take a close look, the terminals of the battery have been reversed. Here I want, and of course the number of cells is also different. Here the current is flowing from the positive to the negative terminal, and in the X wire the current is flowing downwards. This is the wire, and you can see the compass needle which is kept near the wire is deflected towards the right. In the second diagram, the terminals have been reversed and the current is flowing in the XY wire in the upward direction, and that is why the magnetic compass is deflected towards the left. So as I told you, the flow of current is going to have an impact on the deflection or the field which is generated. Now whenever we talk about a straight conductor, now this was definitely a straight conductor. If I place a cardboard in such a way that the conductor is perpendicular to it, on the cardboard we will have the iron filings aligning themselves in the shape of concentric circles. You can see here we have 3 circles around the conductor. So the shape of the magnetic field is concentric circles, that is the circles which have got the same center. जिस भी अलग अलग सर्कल्स का एक ही सेंटर होता है तो उन सबको हम कंसेंट्रिक सर्कल्स बोलते हैं, और स्ट्रेट कंडक्टर की जो फील्ड लाइंस बनानी होती हैं, सो दे शुड बी मेड इन द फॉर्म ऑफ concentric circles with different radius. So this is about the shape of the magnetic field of a straight conductor. If we now we talk about the factors which impact the field. The first factor is the amount of current. B is the field strength. तो जो field strength है वो depend करता है कि कितना current उसमें से flow कर रहा है. अगर ज़्यादा current flow करेगा तो strong magnet बनेगा, कम current flow करेगा तो weak magnet बनेगा. तो हम कहते हैं कि ये direct variation है. So this is direct variation with the amount of current. The second factor is the distance from the conductor. So if the distance is increased, then the field strength is decreased, and vice versa. तो जब हम straight conductor से दूर होंगे तो उसकी field strength हमें कम पता चलेगी, effect will be less. And अगर हम conductor के पास हैं तो field strength जो है वो ज़्यादा होगी. और इसी तरह से आप ये समझ लीजिए कि in this diagram अगर हम x और y पॉइंट्स को कंपेयर करते हैं, y पॉइंट जो है वो कंडक्टर से दूर है तो वहाँ पे फील्ड स्ट्रेंथ जो होगी वो कम होगी, और जो x पॉइंट है दैट इज क्लोजर टू द कंडक्टर तो वहाँ पे फील्ड स्ट्रेंथ का इम्पैक्ट ज़्यादा पता चलेगा. So students, we are going to now study right hand thumb rule. This rule is very important because it helps us to know about the direction of field lines of a current carrying conductor. Now this rule says that if you are holding the current carrying conductor in our right hand, now our thumb points in the direction of flow of current. In this case you can see my thumb is pointing towards the cap of the pen, and I am trying to show the conductor in which the current is flowing upwards. So the manner in which my fingers wrap around the conductor, that gives us the direction of field lines. Look at this diagram. In this the current is flowing upwards and the field lines are anti-clockwise. If you take a look at my hand, the fingers जिस तरह से point out हुई हैं वो anti-clockwise है against the direction of hands of the clock. Whenever the current is flowing downwards, this is how we depict it. My thumb is pointing in the direction of the current. The manner in which my fingers wrap around the conductor will give us the direction of field lines, and when the current is flowing downwards, the field lines will be clockwise. जितनी बारी भी हम लोग को अपना डायग्राम बनाना होता है इलेक्ट्रोमैग्नेट का, तो फील्ड लाइंस बनाने के लिए आपको इसी रूल को रेफर करना है. करंट का डायरेक्शन जो है उसी डायरेक्शन में हमने राइट हैंड का थंब अलाइन करना है, और जिस तरीके से हमारी फिंगर्स उस कंडक्टर के अराउंड मूव रैप करती हैं वो जो डायरेक्शन है वो हमें बताएगा कि फील्ड लाइंस किस तरह से उसके अराउंड बनी है। So this rule, it states that if we hold the current carrying conductor in our right hand such that our thumb points in the direction of the current, then the manner or the direction of field lines is along the direction in which our fingers wrap around the conductor. So this is a right hand thumb rule used to determine the direction of magnetic field lines. Every time you make a diagram, you have to ensure that your field lines are drawn as per this rule. So there are marks assigned for correct depiction of magnetic field lines. If the lines are not depicted clearly or correctly, you will lose your marks. So be very cautious when you draw this diagrams of electromagnets and the field lines or magnetic fields around the electromagnets. Be very cautious about it. And this rule is also known as Maxwell's corkscrew rule. You know, the manner in which the uh, uh, wine opener moves when we are trying to open the bottle of that is the direction of field lines, and the direction in which the corkscrew moves, that is the direction of the current. So Maxwell's corkscrew rule is also used to depict the direction of field lines, and very important rule for all the electromagnets. We have already studied straight conductor. Next I'll be dealing with circular electromagnet. Let us understand the kind of field which is generated by a circular current carrying conductor, and also the factors on which the field strength of this magnet depends. If you take a look at the diagram, in this diagram, the red line is depicting the circular coil. The current is flowing from this part of the coil in the upward direction. Therefore, the field lines as per right hand thumb rule are anti-clockwise. In the other side of the coil, the current is flowing downwards, so the field lines are clockwise. Now, when you have to draw this diagram, please ensure that you are making the field lines as per the right hand thumb rule, and as the diagram is corrected, we always tend to see if the field lines which are drawn by the student are pointing in the same direction inside the coil and in the opposite direction outside the coil. Now, we can also use a clock face rule. Now, this circular coil is kind of a disc, like a ring shaped magnet, and the sides of the coil will give us the poles. And in order to ascertain the north and south pole of the magnet, we can use clock face rule. The part of the coil where the current is flowing anti-clockwise will be north pole, and the part of the coil where the current is flowing clockwise would be the south pole. Now, if we talk about the factors on which the strength of the circular electromagnet depends, first factor would be the amount of current. If there's more current flowing through the coil, the magnet would be stronger. Next factor is the number of turns of the coil. If the number of turns of the coil are increased, let's say we have 2 turns in the coil, then the field strength will become double. If I have 4 turns in the coil, the field strength will become 4 times. Now, it is because of the fact that in every turn of the coil, the flow of the current is in the same direction. So this adds to the strength of the electromagnet. The third factor which tells us about the strength of the electromagnet is the radius of the coil. If the radius of the coil which is taken is bigger, is more, then the strength of the field electromagnet will be less. So three factors in all. Strength depends on the current, direct variation. It also depends on the number of turns of the coil, direct variation again. Third, the radius of the coil, and that is inverse variation. If radius is more, then the current in the coil will be, the strength of the coil will be less. और इस चीज़ को आराम से समझने के लिए एक बार फिर से बात करते हैं सर्कुलर इलेक्ट्रोमैग्नेट की। सर्कुलर इलेक्ट्रोमैग्नेट को हम इस तरह से व्यू कर सकते हैं कि ये दो स्ट्रेट कंडक्टर्स से बना हुआ है और हम लोग राइट हैंड थंब रूल लगाकर फील्ड लाइंस की डायरेक्शन को डिटर्मिन कर सकते हैं। इस डायग्राम में जहाँ पे करंट ऊपर फ्लो कर रहा है तो जो फील्ड लाइंस हैं वो एंटी क्लॉकवाइज है, जहाँ पर करंट नीचे फ्लो कर रहा है जिस साइड पर, वहाँ पे फील्ड लाइंस जो हैं क्लॉकवाइज है। एक और चीज़ जो ध्यान देने वाली है कि कॉइल के अंदर सारी फील्ड लाइंस की डायरेक्शन सिमिलर होगी और आपको ये भी मालूम है जहाँ से फील्ड लाइंस बाहर निकलती हैं वो वाला साइड जो होता है इलेक्ट्रोमैग्नेट का नॉर्थ पोल होता है और जहाँ पे फील्ड लाइंस अंदर जाती हैं वहाँ पर वो वाला साइड जो होगा वो साउथ पोल होगा। कितना स्ट्रॉन्ग होगा हमारा इलेक्ट्रोमैग्नेट ये डिपेंड करता है कि उसमें से कितना करंट फ्लो कर रहा है और कितने टर्न्स हैं उस कॉइल में। जितने ज़्यादा टर्न्स होंगे तो मैग्नेट स्ट्रॉन्ग बनते जाएगा। और तीसरी चीज़ जो फैक्टर जिसके ऊपर स्ट्रेंथ ऑफ इलेक्ट्रोमैग्नेट डिपेंड करता है वो है कि रेडियस कितना लिया है हमने कॉइल का। अगर हमने रेडियस ज़्यादा लिया है तो फील्ड स्ट्रेंथ कम होती है और रेडियस कम लेने से फील्ड स्ट्रेंथ ज़्यादा होती है। एंड दिस इज ऑल अबाउट द सर्कुलर इलेक्ट्रोमैग्नेट। We are going to now talk about solenoid. Solenoid is the third type of electromagnet that we have in our syllabus. A solenoid is basically a coil which is wrapped over a core. So it is having a magnetic field quite like that of a bar magnet. The end from where the field lines are emerging will be termed as the north pole of the solenoid, and the end from where at which the field lines are merging would be termed as the south pole. If we talk about the factors that affect the strength of the solenoid, number one would be the amount of current that flows through the solenoid. It is a direct variation, meaning ज़्यादा करंट फ्लो करेगा तो स्ट्रॉन्ग इलेक्ट्रोमैग्नेट बनेगा। और अगर डिग्री ऑफ क्लोजनेस ऑफ टर्न्स, इसका मतलब ये होता है कि जो हमने कॉइल को रैप किया है कोर के ऊपर, अगर वो सारे जो टर्न्स कॉइल के हैं पास हैं और उनमें एयर गैप्स नहीं है तो मैग्नेट बहुत स्ट्रॉन्ग बनेगा। लेकिन अगर ये कॉइल्स दूर हैं और बीच में एयर गैप्स हैं तो मैग्नेट कमज़ोर बनता है, दैट इज़ अ वीक इलेक्ट्रोमैग्नेट। सो सेकेंड फैक्टर वुड बी द डिग्री ऑफ क्लोजनेस ऑफ टर्न्स ऑफ द कॉइल, एंड द थर्ड फैक्टर इज द नेचर ऑफ द कोर मटेरियल। नाउ दिस इज वेरी इंपॉर्टेंट फैक्टर एंड वी नीड टू अंडरस्टैंड that if it is a soft iron core in a solenoid, then the magnet would be pretty strong, because soft iron core has a ability to lose its magnetism as soon as the flow of current stops. So it gets completely demagnetized, and next time when we turn on the electromagnet it gets completely magnetized again. So it does not have any residual magnetism to interfere. So this is an ideal material for the core of the solenoid. So we've discussed all the three factors and the shape of the magnetic field of solenoid, which is just like that of a bar magnet.